Hey guys, as you know, we have been learning how to graph different functions using the calculus that we learned in class. So I'm gonna review that in one example, and when we have f of x is equal to sine of x plus cosine of x. So there are many ways to do this, but what I like to do is go in order. So if we have f of x, I'm gonna find everything that we can find using f of x. And what is that? We can find, first of all, the x-intercepts and the y-intercepts. So let's do that. First, we have to make this equation equal to 0 and find the values of x for that equation. So 0 is equal to sine of x plus cosine of x. And as we solve for that, we have negative cosine of x is equal to sine of x. So to know what the value of x is, we have to know the unit circle. So here we have the unit circle, and where are the values of cosine and sine equal to, but have different signs. And if you know the unit circle, you know that in pi 4, the values of cosine is square root of 2 over 2 and square root of 2 over 2. But here they have the same signs, so we have to find them with the different signs. So those would be 3 pi fourth and 7 pi fourth, which would be cosine equal to negative 2 over 2 and sine equal to 2 over 2. And in 7 pi fourth, the cosine is pi over 2 over 2, and the sine would be negative 2 square root of 2 over 2. So now we know that the values of x would be 3 pi fourth and 7 pi fourth. Now, to find the y-intercept, we have to find the value of f of 0. So we substitute the values, sine of 0 plus cosine of 0, and f of 0 would be sine of 0 is 0, and cosine of 0 is 1. So f of 0 is 1. So now we have these two things. So let's write them right here. First, the x-intercept, which is 3 pi fourth and 7 pi fourth, and the y-intercept, which is 1. Okay, so now that we have all that, we have to find the first derivative of the function. So let's find that. So f prime of x is equal to the derivative of sine, which is cosine of x, and the derivative of cosine, which is negative sine of x. Now that we have that, we can find the critical points of the function. To do that, we have to set this equation equal to 0. So 0 is equal to cosine of x minus sine of x. And we're going to do the same thing that we did when finding the solution of the f of x. So sine of x is equal to cosine of x. So where in the unit circle are the two values the same? The two values are the same when x is equal to pi fourth and 5 pi fourth. As we know, pi fourth is in the first quadrant, so the values are square root of 2 over 2, and the sine value is square root of 2 over 2, so they're the same. And in the third quadrant, the same thing happens. So here we have the values. So the critical points are pi fourth and 5 pi fourth. We have that f prime of x is equal cosine of x minus sine of x. Okay. So what else do we find? Now we're gonna see where the function is increasing and decreasing. To do that, we have the number line, and we graph the critical point. So we have pi fourth and 5 pi fourth. Oh, by the way, this equation is from 0 to 2 pi. So we begin at 0, and we end at 2 pi. So to find out if it's increasing or decreasing, what we do is we substitute a value that's inside of this range. So inside of this range is 0, and we know that and we substitute it into the first derivative. So f prime of 0 is equal to cosine of 0 minus sine of 0, and f prime of 0 is equal to 1 minus 0, and f prime is 0. So is 1. So we know that the value is positive. And we do the same thing for values inside of each interval, and we're gonna see that when the value is pi half, cosine of pi half minus sine of pi half, the cosine of pi half is 0 minus 1, so the value is negative 1, so it's a negative value. And if we substitute 2 pi, which is at the end of the function, we're going to get the same value as 0, so it's going to be positive. So here we have the number line, pi fourth and 5 pi fourth. So it's positive, negative, and positive. Now that we have all that, we find the second derivative. So the second derivative of x is, okay, we have the first derivative, which is cosine of x minus sine of x. So we find the derivative of cosine of x, which is negative sine of x, minus the derivative of sine of x, which is cosine of x. So we write it down. F double prime of x is equal to negative sine of x minus cosine of x. So what we do now is find the possible inflection points, and we do that by making this equation equal to 0. So we solve and we find that sine of x is equal to negative cosine of x. Again, we have that the values are the same but with different signs, so the values would be the same as the x-intercept. So x is equal to 3 pi fourth and 7 pi fourth. So we write that down. Now we find the concavity. So we do the same thing that we did with increasing and decreasing. We graph the points 3 pi fourth and 7 pi fourth. And we substitute a value. It's the first value would be 0, negative sine of 0 minus cosine of 0. Sine of 0 is 0, and cosine of 0 is 1. So the value is negative 1, so it's negative. Between 3 pi fourth and 7 pi fourth is pi, so we substitute pi. So negative sine of pi minus cosine of pi. The sine of pi is 0, and the cosine of pi is negative 1. So the value would be positive. And we do the same thing for the end of the function, which is 2 pi, and we would get the same value as 0. So it's negative, positive, and negative. So we write that down. And we have that it's negative, positive, and negative. So what do we do now? We can find the maximum and minimum values of the equation. To do that, we can substitute the critical points into the original equation. So we have that f of pi fourth is equal to sine of pi fourth plus the cosine of pi fourth. And when we simplify this, we have that sine of pi fourth is square root of 2 over 2 plus the cosine of pi fourth, which is square root of 2 over 2. And this would give us the square root of 2. So we have that the point would be pi fourth square root of 2. Now we find the other point, which is 5 pi fourth. So we substitute 5 pi fourth sine of 5 pi fourth plus cosine of 5 pi fourth. And we have that the value would be negative square root of 2 over 2 minus the square root of 2 over 2. And at the end, it's negative square root of 2. So these are the two values. Now we can graph. So we have our space, and we know that our y-intercept is 1. We know that our x-intercepts. Oh, let's do this easier. Okay, we begin at 0 and our function ends at 2 pi, and let's just set the values. Okay, so we have that our y-intercept is 1. We have that our x-intercepts are 3 pi fourth, which is right here, and 7 pi fourth, which is right here. We also have that our maximum point is pi fourth and the square root of 2, which is around here, and that our minimum is 5 pi fourth, negative 2. So, using the information that we have, we know that from 0 to pi fourth, the function is increasing. So, we have that it goes up, and that from pi fourth to 5 pi fourth, it's decreasing. So, it goes through here, goes through the x-intercept, and goes to the bottom. And we have that from 5 pi fourth to 2 pi, it's increasing. So it goes up, passes the x-intercept, and it ends right here. And that is how you graph.